In this video, I will demonstrate the patching of a deployment config to configure CPU and memory requests and limits appropriately. As per resiliency guidelines, appropriate CPU and memory requests and limits are critical to ensure resource availability for your own applications and resource availability for other tenant applications. As per general guidelines, always set something for requests and limits. Set the requests to workload's minimum requirements, such as when the workload is idle. Set the limits to a higher, more reasonable value for when the workload is used, and consider using horizontal pod autoscalers wherever possible. Now, these CPU and memory resource values are in the form of millicores, 1/1000th of a core, and megabytes respectively. Jenkins has very low CPU usage when it is idle. As seen here, measured typically under 5 millicores per CPU. Jenkins typically consumes resources when the pod is initializing or executing pipelines. This is where CPU and memory requests can be set very low and their limits much higher to make the pod burstable rather than hogging cluster resources. From the Openshift console in the developer perspective, I'm going to add a Jenkins instance from the Openshift template catalog. And when I instantiate this template, I'm going to use all of the default values as shown here. You will notice that you can only set the memory limit, but you cannot set memory request or CPU requests or limits in here. When I create this instance of Jenkins, it's going to use my project's default limit range to assign those other resource values, which may not be appropriate if the values are not set right for this particular workload. So if I want to patch this with a more appropriate set of resource values, I can use the OC patch command like so, and this will patch the Jenkins deployment config with the following resource requests and limits. For example, CPU as 100 millicores, memory 512 megabytes. For the limits, for CPU, 1 core or 1000 millicores, and for memory, 1 gigabyte. So when I set this here in the command line, this will automatically patch that particular Jenkins deployment config. And when I look at OC get pods here, you'll see that that instance immediately got taken down before I can even run this, and Jenkins-2 is up and running. This will contain the updated CPU and memory requests and limits that I specified up here. Now, if I didn't want to use OC patch, if you instead want to manually update these values, you can use OC edit deployment config, and I can modify the Jenkins deployment config. Simply scroll down to the resources section of the container spec, and here you'll find the requests and limits that I specified earlier. We can modify these values here and save and exit this deployment config, and that'll also update and redeploy a new version of Jenkins with those changes. Now, while this is coming up, you will notice when I run this OC ADM top pods command, this will show us the current actual usage in CPU and memory for that resource. So as I mentioned before, Jenkins takes a lot of CPU and memory resources to instantiate itself, but after a couple of minutes and after it becomes pretty much idle, you will see that CPU usage come down to very close to 0 millicores. Now, when a cluster node's CPU is being heavily utilized, pods that are above their CPU requests but within their limits may be throttled to prioritize other workloads. When a node is running out of memory, pods that are above their memory requests may be evicted. Pods that go beyond their memory limit will be immediately terminated. So, resource quotas are defined per project to assign the maximum total CPU and memory requests and limits a project is allotted. We can see that by going back to the Openshift console. In the administrator perspective, Down here, administration, resource quotas, and in this case, we're dealing with the compute long-running quota. In here, you will find the actual used, and the maximums of your project's CPU and memory requests and limits. You can also view this from the command line using a command like oc get resource quotas. Now, in the event of a cluster administrator needing to shrink project resource quotas, you might see an overallocation of your resource quotas. So this might look something like this in the UI. This might not cause any immediate termination of your workloads. However, when a pod is evicted or terminated by any means, a new pod will not be able to come up and replace it if these resource quotas are at or above capacity. It is important to patch your workload's resources accordingly to ensure you are within your allotted resource quotas and to avoid any downtime.